For next subtopic, we will learn about first shift theorem. So first shift theorem we apply whereby you have exponent multiply with any function of ft. So you can refer to the textbook theorem 4.2. First shift theorem, Laplace exponent at multiply ft is equal to the fs minus a. Okay, so this one we can refer to the table of the Laplace transform. Okay, from the table of the Laplace transform, this is the formula for the first shift property. You have exponent multiply with any other function of ft, and the formula is fs minus a. So if you refer to this one, you have exponent multiply with the sine bt, exponent multiply with the cos bt, and exponent multiply with the t the power of n. So for this type of the function, we already have the answer here directly from the table. Okay, but if the question mentioned by using first shift property, we cannot use the answer from the table. You have to solve by using first shift property. So what is the step for the first shift properties? So for the first step, you have to determine what is the value of a, what is the value of ft. The second step, you have to find the Laplace transform of ft, whereby we will get the fs. The second step is we will shift the answer, which is from fs will become fs minus a. So there are three steps in order to solve by using first shift property. So let us try to solve this example by using first shift theorem. Find the Laplace transform for the following function. So it's already stated in the question by using first shift theorem. So example A, ft is equal to t the power of 2 exponent 3t. If you can refer back to the table, exponent at multiply with the t the power of n is already in the table, whereby the answer will become n factorial over s minus a n the power of 1. But now we want to solve that question by using first shift. So the first step, you have to determine the a, you have to determine the ft. The second step, you have to find the Laplace transform for the ft, whereby you will obtain the fs. The third step is you have to shift the fs to become s minus a. Okay, for the example 1, ft is equal to t square exponent 3t. Okay, so you have to determine the a and you have to determine the ft. Okay, so this ft means that is new ft, because you are given ft is equal to t the power of 2 multiply exponent 3t. Okay, so our a is from the exponent, a is equal to 3. So this is our ft. Okay, so ft is any function except exponent a t. So that's why we take the t the power of 2 as our ft. So now for the second step, find the fs from the ft. So our ft is equal to t the power of 2. So fs, whereby the Laplace transform by referring to the table, t the power of n, n factorial, s n plus 1. Okay, so based on our Laplace transform here, our n is equal to 2. So our n is equal to 2, so therefore n factorial will become 2 factorial over s2 plus 1. So 2 plus 1 will become 3. So 2 over s the power of 3. So now for the last step, we want to shift fs minus a. So our a here is a is equal to 3. So therefore, fs minus a s minus 3 is equal to 2 over s minus 3 the power of 3. Okay, so we'll change the position of s here to become s minus 3. So this is the answer for the first example by using first shift property. So now let us continue for the next example. ft is equal to exponent negative 2t multiplied with the cos 3t. So first step, you have to determine the a from exponent, and your ft is the new ft which is accept exponent at. So from here, our a is equal to negative 2, and your new ft is equal to cos 3t. So from your new ft, you have to find the Laplace transform, which is the result will become fs. So Laplace transform for the cos 3t, by refer to your table, cos at is equal to s over s square plus a square. So from here, your a is equal to 3. So therefore fs will become s over s square plus 3 square. So s square plus 3 square will become s over s square plus 9. Okay, so now for the last step, step number 3, we want to shift fs to become s minus a. So our a is equal to negative 2. So therefore fs minus 2 will become s plus 2 why s plus 2 here, because s minus 2 is s plus 2 over s plus 2 square plus with 9. Okay, so we already shift all the value of s here to become s plus 2. So for this example, I will discuss from exercise 4.3, page 135. By using properties of the Laplace transform, find the Laplace transform for the following function. So if you want to solve by using the first shift property, it must be exponent multiplied with any other function in terms of ft. If you want to apply the linearity properties, it must be in terms of plus or minus operation between 2 or 3 functions. So for the exercise A, 5t the power of 3 multiply exponent negative 2t. So we have exponent multiply with the t the power of n. So this one you have to apply the first shift property. We have 5t cubed exponent negative 2t. So this is the step in order to solve by using first shift property. You have to determine your a and your ft. So our a we get from the exponent negative 2t. So a is equal to negative 2. So our ft, which is any other function except the exponential term, which is 5t the power of 3. So now from this ft, you have to find the fs. So fs, by refer to your table, t the power of n will become n factorial over sn plus 1. So from 5t the power of 3 here, you have 5 at the front here. So means that 5 is a constant that you have to bring to the outside. So this is the linearity properties. 5 multiply with n is equal to 3. So n factorial, which is 3 factorial, 3 factorial over s3 plus 1. So 5 multiply with the 3 factorial, the answer will become 30 over s the power of 4. So now we will proceed for the last step. You want to shift the answer fs minus a. So our a is equal to negative 2. So therefore fs minus 2 will become s plus 2. So we will shift the position of s here to become s plus 2. So 30 over s plus 2 the power of 4. So this is the answer for the exercise A. So for next question, we have exponent negative 4t multiply with the sine 3t. So exponent multiply with the another ft. This one we also have to apply the first shift. So this is the step for the first shift. The first one, you have to determine the a and ft. So a is equal to negative 4. So from exponent negative 4t, a is equal to negative 4. So our new ft, which is any other function except the exponent. So our new ft is sine 3t. So from ft here, you have to find what is our fs. So by refer to the table, if you have sine at, the answer will become a over s square plus a square. So from sine 3t, our a is equal to 3. So therefore, sine 3t will become a over s square plus a square. So a is 3 over s square plus 3 square. So simplify the 3 square, s square plus 9. So for the last step, we want to shift the fs become fs minus a. We will have s minus 4 will become s plus 4. So we will shift the position of s here to become s plus 4. 3 over s plus 4 square plus with 9. Okay, so you don't have to expand the denominator. So that is the final answer for the exercise B by using first shift theorem. So next exercise, exercise C, you have cos 2t plus 1 over 4 sin 2t, which is multiplied with the exponent 2t. So any function that is multiplied with the exponential terms, we have to apply the first shift. Okay, so this is the step in order to apply the first shift properties. So for the first step, you have to determine the value of a and then determine your new ft. So from exponential 2t, our a is equal to 2. So our new ft is any other function except the exponential terms. So this is the whole thing as our new ft. So new ft is equal to cos 2t plus 1 over 4 sin 2t. So from this new ft, we want to find the fs. So second step from new ft, we want to find our fs. So fs is find the Laplace transform for the cos 2t plus 1 over 4 sin 2t. So we know that when you have the plus operation in the middle or minus operation, we have to apply the linearity. Apply linearity means that you have to bring any constant if you have to the outside. So for the cos 2t, refer to the table of the Laplace transform. So from the table of the Laplace transform, we have cos at is equal to s over s square plus a square. Sin at is equal to a over s square plus a square. So now we will substitute the answer from the table of the Laplace transform to the Laplace of the cos 2t and the sin 2t. So cos 2t, our a here is equal to 2. And from sin 2t, our a is also equal to 2. So therefore, Laplace of cos 2t, we substitute s over s square plus a square. S over s square plus 2 square. Plus with, plus, we have 1 over 4, which is 1 over 4 is a constant. 1 over 4 multiply with sin 2t, substitute the answer for the Laplace transform sin 2t, which is a over s square plus a square. So our a is equal to 2, so substitute a become 2. 2 over s square plus 2 square. So now you have to simplify. S over s square plus 4 plus 1 over 4 multiply inside. 1 over 4 multiply 2 will become 1 over 2 over s square plus 4. So now continue for the last step. We have to shift the s here become s minus a. So from the above, from the first step, we have determined our a is equal to 2. Fs minus 2 is equal to every position of Fs that contain s, you have to shift the s become s minus 2. So this s will be substitute s minus 2. S minus 2 divide with s square will become s minus 2. S minus 2 in the bracket square plus with 4. So we plus with 4 plus 1 over 2, and we just substitute 1 over 2 over s square. We substitute s minus 2. S minus 2, the whole thing bracket square plus with 4. Plus with 4. So that is the final answer for the exercise C. You don't have to expand anything at the denominator.